All right, guys, today we're going to start our section of solving system of equations. There's three ways to solve a system of equations. Number one is graphing, two is substitution, and three is elimination. I'm going to show you right now the graphing part. Okay, so let's start up with the top. It just says graph the system, find the solutions, then check the solution and classify the system. So basically what we're going to do, guys, is we're going to graph the two equations, and then where they meet is the solution. But you can classify each solution also. So let's look at the classifications, which are right here at the top of your paper. Consistent is if a system has one or many solutions. Inconsistent is when it has no solutions. Independent is when it has one solution, only exactly one. And dependent is a system with infinitely many solutions. So when we graph these, we will be able to pick out the classification also. So let me scoot this up just a smidge. Okay, now look at all three of these. I was a little mean when I did this. So if you're looking at all three, are any of these solved in y equals mx plus b? No, they are not. And again, I do this, because we need to practice it. It's important to be able to solve these. Okay, so let's start with this first one. I'm going to move this 3x to the other side. If it's positive over here, what's it over here? Negative. Good. So I have negative 3x minus 30. Now remember, you're going to divide everybody by negative 5. So we're going to have y equals 3/5, because negative and negative make a positive, plus 6. All right, here we go. Let's graph it. So we start at 6. 1, 2, 3, 4, 5, 6. And we're going to go up 3 over 5. Well, up 3 over 5 is like right here. It's way off the grid, okay? So then let's go down 3 over 5. 1, 2, 3, 4, 5. Okay? So now let's draw our line. All right, there she is. Beautiful line. All right, let's do the second one. Again, solving for y first. I'm going to bring that x to the other side, which again makes it negative. I'm going to divide everybody by negative 5. So I'm going to get 1/5 x plus 4. Okay? See, negative and negative, that makes a positive. Negative and negative, that makes a positive. So I'm going 4. 1, 2, 3, 4. And I'm going up 1 over 5. 1, 2, 3, 4, 5. Down 1. 1, 2, 3, 4, 5. Now, you don't ever want to be stingy on your dots, you guys, because you don't know when they're going to cross. So there it is right there. Now, where the two lines intersect, that is your solution. Okay, so they intersect right here at this dot, so that looks like 1, 2, 3, 4, 5, 1, 2, 3. So negative 5, 3. That is the solution. That right there is the solution. Now, let's classify it. So, is it consistent or inconsistent? Is it one or many solutions or no solutions? Yes, one or many. So it is consistent. Now let's look at the other two. Is it independent or dependent? It has one solution or infinitely many? Good, one, independent. All right, that's it. That ain't bad. The only part that should suck is the solving for y part, not anything else. You guys should be okay at graphing. Let's go again. Let's solve for y. I'm going to move that 2x to the other side. Then I'm going to divide everybody by 4. All right, now you see this 2 over 4? You need to reduce it. So that is 1/2. 12 divided by 4 is 3. All right, let's do it. Start at 3. Down 1 over 2. Down 1 over 2. And again, no stinginess. Make as many dots as you can, because you do not know where these are going to cross. All right, first line done. Now my next one. Again, I'm going to move this x to the other side, which makes it a negative. Then I'm going to divide everybody by 2. So I get y equals, looks like negative 1/2 x plus 3. Ooh, something shady's happening. Look at the yellow. Look at the purple. What do you notice? They're the same. So if I go and try to graph this, it'd be 3, and I'd be down 1 over 2, down 1 over 2, down 1 over 2. It's the same exact line. So every point that's on the yellow is also on the purple. So what do you think you call that when all of them are the same? Infinitely many. Okay, so if you ever are graphing, having a great time, and one line is on top of the other line, that means all the points match. All of the points, infinitely many, because those lines go on forever and ever and ever and ever and ever. Okay, so now let's classify it. So is it consistent or inconsistent? Good, it is consistent because it's got many solutions. Is it independent or dependent? Good, it's dependent because it has infinitely many solutions. See, not that scary. The scariest part is solving for x, or solving for y. All right, let's move over on our last one. Okay, again, going to solve for y up here. So I'm going to move that x to the other side, so negative x. Then I'm going to divide everybody by a negative 1 because that y is negative. So I'm going to get y equals x minus 5. Okay, so start at negative 5, up 1 over 1. And again, do not be stingy with the dots. Okay, there's my first one. Switching pens. Move that 2x to the other side. It's going to become a negative 2x. Now divide everybody by negative 2. So we get y equals x minus, looks 4.5, 9 divided by 2, 4.5. So we're starting at negative 4.5. 1, 2, 3, 4, and a little bit more. Then I'm going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it's right beside it. It's just kind of hanging out right beside it. Is it touching at all? No. What are these lines called? Starts with a P. Parallel. So anytime you get parallel lines, see how they're not touching at all? They're not going to have any intersection. So this is actually none. So there's no intersection. So let's see. It is inconsistent because it does not have a solution. And then we do not classify it down here because look, independent has 1, dependent has many. So there's no classification for that. So there are 3 different things that you can have when you're doing your homework. You can have where it hits one solution. You can have where it's infinitely many, it's on top of each other, or you can have none. 3 different ways. Again, try out your homework and your practice problems.